Sure, all ashore who's going ashore. So welcome to the 3:30 session on critical zone observatories. How many people here have heard of critical zone observatories? Okay, so everyone who's heard of critical zone observatories sit on this side of the room. This side of the room is for the groom's side. This is the bride's side. So I think we have a great afternoon ahead for you. So we have speakers from 3 different observatories. We'll be talking about the particular challenges of their location and the technologies they're using for data management. We got some background on the project and some fascinating surprise news about what's happening next, but I won't give that away. So I'm Ben Galuski, I'm your facilitator today. We'll be having some discussion with Colin Bodie from Berkeley, Luigi Marini from my hometown of NCSA, University of Illinois, Martin Soyle from Quasi, is that how you, Quasi, and a remote participant from an undisclosed location, David Lubinsky. So we'll start with an introduction to what are critical zone observatories and some of the history with Colin.
Thank you, Ben. All right, so I'm going to do 2 short talks in sequence here. And the first one is about cyber infrastructure in the critical CZOs themselves. And so this was cyber infrastructure that was developed for all of the CZOs. Then I'm going to shift gears and just talk about my personal experiences as a data manager for a particular CZO. So when we were structuring this talk is a little bit on approaches taken, the tools used to apply those approaches, and lessons learned, good or bad. And the participants here are not just the CZOs, but also Quasi, and NCSA. I couldn't help myself. All right, for everybody on this side of the room, what is the critical zone? It's not a very obvious term. So basically, it's the Earth's permeable near surface layer. It goes from just the air above the tops of the trees all the way down to the bottom of the groundwater and the impermeable rock. And it's a vertical definition, it's terrestrial only, and it's basically where all life as we know it exists, pretty much terrestrial. And that's why we care about it. And the things that we study on it is its structure, the vegetation, soil, saprolite, the weathered rock, and then the processes that evolve that structure and either maintain it or alter it over time. And finally, the fluxes that are mediated by that structure. And the most obvious one's water, but you also have solutes, you have sediment, you have biota. All of these are mediated by the critical zone. Okay, well, at least we know what that is. What's the observatory part? So we're critical zone observatories. This was an NSF program that's, the orientation was place-based research. You go to one spot and you bring people from multiple disciplines to work at the same spot. It's a necessarily cross-disciplinary question to get at these, because as you go down through the various layers, you're switching disciplines. And so the idea was pick several sites, have cross-disciplinary teams interact with each other to really get at these questions of how does the processes work. And one of the specific things is because of the fact that you had these cross-disciplinary teams, it's not a single PI situation, they required a data manager. So it's been through several evolutions. It started out quite small, there's 3 CZOs, and then there's 2 expansions that's occurred since then. We're currently up to 9 observatories, and you can see we have a number of collaborators and people who are involved with the CZOs. I'm going to talk a little bit about its history. This is from the perspective of the data managers. There's 3 eras. They don't quite match with the expansions. It's more a function of what happened in the attempts to manage the data. And I'll go through these piece by piece. Also, these eras were influenced by the actors, the PIs, the data managers, the developers who actually worked on the cyber infrastructure. It's actually a fourth one, which is actually NSF itself. Has had a heavy influence on what we've actually done. So the first era I call loose federation. So at this time, the CZOs were standalone sites. The focus really was that each one had a separate research question that they were going to solve at their own site. The data was managed locally, but there was a kind of a general agreement that it'd be nice if we could say, hey, what do you have? And have a centralized catalog of some sort that federated the various locally managed data sets. First attempts at working at this, we adopted ODM 1.0, which I believe originated with Quasi, and something called the display file. And honestly, I've yet to find out why it got called that. Basically a text file metadata, but it didn't have any structure to it particularly. It just had essentially a set of agreed upon protocols that were not enforced. These two were combined in something called CZO Central. So some of the lessons learned from this was ODM1 was good for time series data, but we tried to use the display files to kind of shoehorn everything into it. Didn't work very well. Some people succeeded, most didn't. Also, we didn't end up with a centralized catalog, and so we started talking about just using a website to do that. By the way, that incomprehensible thing, that's a display file. I don't expect you to read it. Second era was called the all-in-one databasing. Essentially, as a response to the first period where people were bothered by the limitations of what was going on, there was felt a need to vastly expand kind of the interoperability, the flexibility of any system that manages the data. Also, at the same time, NSF refocused the CZOs not to be focused on their place with interdisciplinary work, but rather that you wanted the science to occur between CZOs. So the CZOs were supposed to operate as a network. So the centrality of data was much more important. And also people started asking for things like, can I combine iron with discharge, which at the same time period. So kind of a granular data combination. This resulted in 2 NSF grants to try to do this kind of work, Big CB and CZO data. The national office was formed at this time, and the central website, which the invisible voice from above, David Lubinski, runs. You'll hear from him later. Undisclosed location. So out of these grants, several tools that I've listed here resulted. However, some of the lessons of this period was the scope of effort was too broad, tried to do too much. And a lot of it was a little too much, it was too hard to implement. Yoda, which was supposed to be a replacement for the display files in YAML, never was finished. The Big CV portal was not fully adopted. ODM 2.0 was partially adopted, but not fully implemented, except for CZ Manager, which one of the data managers, Miguel Leon, did on his own with no grants, and actually makes it work. It's a pretty impressive piece of work. The national website, national office website is still our central data catalog, despite all this. One of the problems was a mismatch between the priorities of the grants as they were written and the needs of us data managers. The people on the grants didn't really were required to fulfill what they'd written and what got approved by NSF, even though they knew that we didn't need that. We need something different. And there was no flexibility to adjust to make these grants meet our needs. As a result, there's a very low level of adoption of the tools that were built during this time period. Also, finally, some of the tools, minor note, vendor lock-in. They use very specific licensed sets of software, which a lot of us neither had a license for or training in. And as a result, we're like, don't want to use it. Last error, I'm not going to talk much on this slide. This is where we are now. Again, the attitudes have shifted. Cloud storage is a thing. Repositories have become much more mature. And so we're opting, instead of separate local management of data, we want to centralize the management of data. And we have a very small budget. So the tools are, we're adopting Quasi's HydroShare, which you'll hear about in a little bit. And we're using some of the previous tools from ODM too. And we're looking into some of NCSA's Clouder for working on this as well. And David Lubinsky will talk a little bit more about this. So I'm going to switch gears now. So that was kind of a brief overview, just to give you an idea that we've gone through this kind of history of different attempts to try to manage either individually as a single site or as a group. At the same time, as data managers, we're still managing our own data through this. So this was, my next set of slides is going to be what I've been doing personally. I like the little bounce. Okay. So I just wanted to give a quick shout out to Scott Smith. He's the software architect I work with on Dendra. And I'm pretty damn lucky to work with the guy. So, I'm working with the Eel River CZO. I'm the data manager for it. We're located in California, Northern California, so south of here, on the Eel River. It's actually a river that flows north. They exist. And even though we do surveys along all of the Eel River, most of our work is at a single owned by the UC Natural Reserve System, a wildlife refuge. So we can actually control access to the equipment we set out. So for the Eel River CZO, we're really interested in upland hill slopes and the unmeasured zone. This is the area of weathered bedrock, which is heavily fractured, and you have a considerable amount of water storage that occurs in it. It's also incredibly hard to monitor. But we're very interested in rock moisture because we're finding that, at least for the California Coast Range, most of the water is not stored in soil. If you run something like Top Model, it's a complete failure. It just doesn't work in our area because it only has soil. At least the older versions do. They may have updated it. It's mostly in the rock. So rock water is a thing. So how do we do this? Our approach is intensive monitoring. This is the Angela Reserve. We're looking west over, this is LiDAR imagery here. It's not photograph. And we have a lot of sensors. I have built a wireless network and set up a real-time sensor observatory out at this place. And most of the sensors are actually in one little spot. The data comes in at about 5-minute interval, and it is, I'll show you what, we got a lot of them. So one of the problems with implementing something like this is, well, we have 40-meter trees. It's mountainous. Wireless, we don't have any cell connection. There's no internet out in that area, at least by normal standards. Half the time you can't get a GPS signal. It's rough.
Colin, sorry to interrupt, but we're just seeing your first slide, so I don't know if the other slides are showing there in the room.
Huh, interesting.
Is there a setting that can be adjusted?
You know, it's usually it's real simple and hacky, which is just great. Just undo it and then do it up again, and now it should be good. Oh, and also we need to do one more thing. It's gonna be showing the main screen. We want to be screen 2, and there we go.
Turn it off and turn it back on
Thank you.
again.
Yes, exactly.
I like it. Do
Great.
we have to kick it too?
Thanks for that.
All right, appreciate it.
Looks good.
Just
Thanks.
slide.
This is the slide to see.
Okay, so we use trees as towers. We put solar panels at the tops of trees, and right there, that's a Cambium Networks high-speed backhaul for wireless networking. So I'm not so much a data manager as I am a sensor observatory manager, because I put the equipment in, I manage the network, I also do the data management as well, but it's part of what I do. And, you know, I can't really resist.
Oh, sorry, you have to click on the PowerPoint again. Or else it will.
There?
Yes.
Thank you. I'll just keep hitting it,
Yeah.
hoping for a different solution.
This is 2 years of experience.
Like, come on. And I couldn't help putting this in. This is a redwood that we equipped called a Reb. It's 50 meters tall. I got to see the backs of pigeons flying below me from there. Awesome. Also hard to pull things up at. So on the ground, we use fairly standardized equipment. Campbell Scientific, we've tried multiple different kinds of experimental data loggers over time. Every single one of them failed. A $40 piece of equipment costs several $1,000s in my and other people's time. So using expensive, reliable equipment was cheaper. We just use a lot of them. I'm still waiting for someone to make that reliable, cheap item. If you do, contact me. And banana slug, awesome. Go banana slugs, I'm from Santa Cruz. So we do have some innovative devices. I can't go into this very much because of time, but this is the Vados monitoring system. It's a 45-degree angle borehole that was drilled into a hill slope. And that sleeve you see there has sensors all along the outside of it, along with tubes for pulling water in. It was inserted into the borehole. Concrete was poured through the center of it, pushed the sensors out. And so this is one of the only ways you can actually monitor the unmeasured zone. There's only one, this is one of 5 in the world. So it's pretty cool to have. It's also very bizarre. So in the same area, we have about 800 sensors. So in a lovely shoe shape. We've actually extended south, so it's no longer as pretty as it used to be. I'm not going to go through them, but I just want to give you a feeling for the amount. We have 20 different loggers, 800 sensors in an area that's about a half a kilometer by 300 meters. Intensive monitoring is what we do. So obviously, you need somewhere to manage that data. It's coming in at 5 minutes. It's a lot of data. Dendra is the sensor observatory curation system that I built along with Scott to manage this data. It's been going, it's the 2nd generation of what we've done. And we're currently managing about 1.3 billion records. And we have 3 organizations that use it. It's not just the CZO. Now, if you're interested in the software stack, talk to me afterwards. Happy to talk more about it. Scotty already has pulled my ear a bit about it. And I'll talk a little bit more about the features. We are hosted on the XC Jetstream system. So one of the things that I've needed is a live system status. I need to know when things go down. So questions like, is the network out? Is the power going out? I want to see this very quickly. So we have a status dashboard. It doesn't show me, that's actually spark lines of battery voltage. We have individual dashboards for full-fledged weather stations. So you can pull it up on your phone. You get the nice little blocks, gives you, oh, hey, it's warm today. You can do that pretty easily with these. Finally, if you're a researcher and you're actually trying to query the data and download it, we have a query interface. And it split things up by medium, rock, soil, air, leaf. Battery is actually a medium. and the variable, that the thing that's being measured. And these will give you the data streams that you can pick and choose, and then you can graph them and pull it out, take a look at it, and if that's what you want, you can download it. You can also do multiple graphs, so you can go back and forth until you get exactly what you want. Or if you want to compare two different graphs to each other, it's very convenient. So this is good both for troubleshooting and your first cut at looking at the data. Now, research meets nature. Nature usually wins. This is an ant colony. It was a cold winter. They decided that a great place to put their eggs was inside my radio. It was powered. It was warm. They have formic acid. It's dead. So they're also native, so I couldn't like use chemicals on them. So what you're seeing here is an incident report. Now, what we do is anytime nature interferes, or worse, graduate students, we actually write a report. It's a pretty simple process. It says what was affected, what is the time frame affected, and is this data to be excluded? This was not to be excluded. Network failure valid. The data is valid because we had a network failure. All the data was stored locally, and then once the network was back up, everything what happened, but it was highly entertaining, so I wanted to record the event. And I had to replace the equipment, which is expensive. So this kind of report goes into what we have, which we call a flag and translate system. You submit a report, the annotation, as it's called, is processed. The flag is assigned to the various data streams, the instruments, not individual data points, not yet. You can flag it as invalid. You can also say, I did a calibration, this section of area, I'm almost done, really, needs a calculation adjustment. And then you can adjust for that time range. And however, the source data never changes. This is translated on exit from the system. So if you get a graph or if you download the data, that's when it occurs. And the nice thing about this is this creates a dynamic versioning of data sets. So think of it like GitHub for data. You can actually go back in time to a period where perhaps somebody put in an annotation incorrectly, or you want to match a model that you pulled data from 2014 and they didn't have the current corrections to the data. So you want to go back to the bad data, rerun the model, match the person's output, and then go to the new set of data and run it again. You can do that with this system. So the example here is I have a well annotation where a graduate student pulled the pressure transducer out of the well and stuck it on the ground next to him. That's those big spikes. That's not real data. That's a dude pulling a pressure transducer out. He submitted his report, and this is what happened literally 15 seconds later. So it's instant response to the annotations, source data unchanged. You can go back and forth between these. So non-time series data sets. I'm going to go quickly through this. Basically, we have a lot of other data sets at the CZO. However, well, I called myself a sensor observatory data manager. I'm not so good at that. I've focused on one thing and not the other. So this is the slide I tend to show graduate students, which basically says, please do a really good README. As a result, I have struggled a lot with the data management of non-time series data. And I'm hoping to work with these two people to improve that. And you'll hear from them in a minute. So some of the lessons learned, there's some benefits to designing systems that are very focused on doing one thing very well, as long as you understand the limits of the system. Obviously, I just told you one of the other lessons I've learned. And this is a view from one of the trees on a fine spring morning. So with that, I'm going to hand it off to Luigi.
Template looks familiar.
Yeah, that's it.
Oops. Go. Thank you. Good afternoon, everyone. So like Colin, I'm a special kind of data manager. My background is actually in software development, and I develop a lot of cyber infrastructure. And at some point, one of these CZOs was starting, and they asked me to take that role for IML. So one of the biggest challenges for me was to try to understand enough about the science and the instruments to actually be effective. So because of that, I'm going to focus on this other CZO, IML, and then talk to you about some of the data frameworks that we have been using to manage the data at IML. So here's a nice cartoon of our PI telling you about the science. So the IML, Intensively Managed Landscapes, has 3 main sites. They are in the Midwest, so it's farmland. There is a lot, and the big questions that they ask is how humans have modified the landscape to produce food, right? And you'll be surprised the kind of things that have happened to these kind of farmlands to make that happen. Unlike most of the other CZOs, there is 3 main sites instead of 1. And of those, really, Illinois and Iowa are the ones where we get streaming data, on a daily basis. And there's many institutions involved in it. So this is the kind of data that we get. So there's a lot of data that is streaming in from a bunch of sensors. That's a picture of an Ameriflex tower that the CZO put up and maintains. We get all sort of different, we have all sort of sites with all sort of different sensors. We also had 2 flyovers to get some LiDAR data sets at both locations. A lot of lab analysis results, primarily soil cores, and some GIS layers. So obviously our task is how to get all this data in real time, put it all in one place, and make it available not just inside IML, but also to other researchers interested in this data. And so when the project started, we had been working on one framework called Clouder, which was a data management framework that was not domain specific, is not domain specific. So earth science was just one of the different domains to which we applied it. But as you can see on the right, there's all these other domains that we applied it to. And the reason why we talk about long tail of data and what this framework does for us is that we can adapt it by extending it with doing the following things. So primarily, it's your usual kind of web-based data management system. You put in files, you organize them, and you can share and publish these data sets. But more importantly, it has a really flexible metadata representation. This is all JSON linked data that you can attach to files and data sets. So it's really, really flexible. You don't have to define that ahead of time. And you can trigger executions of arbitrary code behind the scenes as the data kind of flows in, right, from the sensors. And I'll give you an example of that in a second. And also visualize the data in different ways. So this is an example where when the project started, we had this. So we decided, okay, this is a good fit. Let's apply it. And so one of the ways that we applied it, so this is a simple example of what happens behind the scenes, is if you have geospatial layers, and so the users of the CZO can upload, geotiffs and shape files directly and to share it with, fellow researchers. I'm not going to go into the specific, but basically the way you will get in Clouder a map that you can interact with is by having these extensions behind the scenes. And so the bottom line, I'll move quickly past this slide because it's a little bit too detailed, but the bottom line is that what Clouder allowed us to do is put all these files in and then customize the interaction and the visualizations with the data in different ways. And in this case, we leverage the GeoServe and different OGC standards so that you can use things like QGIS out of the box. We don't have to build them, right? So we had this, and then we had another tool that we had been building for another project. And this was kind of different because this tool was very specific to a use case. And so we decided to take that and create kind of a dashboard interface with time series and different graphs, the same way that Colin kind of described, his work. But in our case, in this case, this was very specific to some work that we had done with the Great Lakes National Program Office. And so there were a lot of inherent assumptions that I'll show you did not necessarily map very well, to IML, basically, to the CZO. So really what we did was we said, okay, this is probably what every CZO somewhat did, was we have data streaming in from data loggers. We want the raw files to end up somewhere. In our case, it's Clouder. And then we want to extract from these raw files these kind of data points and show them on a map with interactive graphs that allow people to just download the kind of curated information. And then everything else goes into Cloud, right? Any other type of data files. So for example, with the Flux Tower site, we also, for this particular one, use Campbell Scientific. So LoggerNet, we have data coming in every hour, 15-minute interval. That's what we streamed, over the cell phone network. Then once a month, somebody goes out there and actually gets the raw data, which is a much higher resolution, and then they manually upload it to Cloudr. If you look at this, I mean, there's 158 columns. It's a lot of information. So if somebody wants, right, we put it into Cloudr, they can go to Cloudr. There's a web UI, and they can download that data, right? So they can have the full data that was basically outputted by the data logger. And so this is really useful. Some people like to do that. We also do all sorts of things in terms of aggregating. So we started by just putting these really small files that were 1-hour files in here, and then you would download them and get so many of them. And the researchers were like, this is too much. How do I concatenate them? So we put in a little, kind of pipeline that aggregated by day, that aggregated by year, and now they're much happier. But these are things that you learn from experience. You can also, another lesson learned here was that we have this ability of having project spaces where you can basically say only certain users have access to Flux Tower data versus some other sites. Well, as it turns out, people log in and they just want to download everything. And so we have to manually add them to all these spaces. And so we have all this permission, setup that in practice is not, it's actually somewhat counterproductive, at this point. The other thing is that Cloudr is very much, kind of like social curation. You create your data set, you put it there, and then you share with everyone else. Well, what happened in the first phase of the project was that people were just randomly creating data sets. They were not curating them. And so they were really hard to find. There was no formal structure, right? And so we actually had to create that structure. And this is a spreadsheet that somebody on the team, that we created, where we said, okay, so the spaces are going to be like surface water, and then the collections are going to be one for quantity, one for quality. And then the child collection are going to be, in this case, stage, stream flow. And then we're going to have the sites, the data sets are going to, represent the sites. And so this is an interesting case where you have this generic tool and you have to apply it to one particular use case. And you think that there's enough activity around it that people are going to be tagging, and, you're going to, naturally kind of like come to the top. And in practice, these are very busy researchers. They just want to put their data somewhere, download it, and then work with their tools. So we have to put some structure on our system. Another interesting thing was how we support metadata. So you can go in and you can set up your own standard vocabularies. We see ODM2 there, CSDMS. You can create your own fields, and you can say it's of this type, and I want users to come in and tell me, the spatial reference. And so you can do all this work. And then we said, well, to simplify putting data in, we don't want to require any of this information. It's much quicker to put it in, and then the community will help curate that. Well, again, the community really didn't have time to do that, right? So we have all these files in there, right, with basically lacking metadata. I mean, we have a very sophisticated system, but in practice, it has been a challenge to actually get people to put in metadata. Some have, so it's not everyone, but, it has been a challenge. Another lesson learned is that, we have all these parsers. So for every different sensor that we have, every feed, every data logger, we write a Python parser that basically takes whatever is in the data file and transforms it in a format that gets ingested into that dashboard that I'll show you in a second. And again, we started by just saying anybody writes some Python code using requests, right? And then just, make it happen because we have a RESTful API. Well, that soon we realized that different developers were doing it differently. It was really hard to maintain. And so what we did was, created a PyGeotemporal wrapper on that. And then eventually we got to the point where we understood enough about the commonalities of all the different feeds, where we're able to write a simple library where you write a YAML file. You say, well, this is the definition of the sensor. These are the columns in the CSV file. And then it just runs and puts it in as data points, right? It might not work for all use cases, but it was kind of interesting to see how we got to that point. So once you get data in, this is what it looks like. Again, similar to what Colin showed, those 154 columns become 23 instruments. Each instrument actually has a bunch of parameters on it. It's not just atmospheric data from the flux tower, because we also get like soil probe, so the location itself, the modem sends over a bunch of different data from a bunch of different instruments. And then we just plot it on, the web in a way that you're, kind of used to seeing. We also have box and whisker plots and so on. You can zoom in and out. I'll tell you a little bit about that in the end. So when you zoom out in the dashboard, you get all these sites, all these sensors. They're categorized by sources of the data. And this was something that we got from that other project. But right away, sources, it turns out that it just did not make much sense to the users. And they wanted to use things like, I want to browse by parameter type. I want to browse by this category, in terms of the kind of research. So we had to extend the dashboard to support all these ways of actually kind of browsing through the different sites. And that's what you see on the left. And so that's something that we had to do as part of the project, because the original kind of, setup was just not very helpful. We also, we had this search interface. It's kind of interesting, where the goal is, there's all this data coming in, and if you're just working one piece, then that's fine, you know what you want. But like, Colin was saying, Critical Zone is very much about bringing together, right, all these researchers from different disciplines. And so we built this interface that allows you to, across all the sites, basically filter down to the data you want. So in this particular case, I started with locations, but I could have started with data source or parameter. And then based on my first pick, then the second list will be a subset of that matches the first pick. So I picked data sources that are in Sangamon River. And then based on the data sources, USGS, Critical Zone Observatory, Illinois State Water Survey, then I get a list of parameters, and I decide, to pick the parameters I want. As you do this, the sites on the right, you see them kind of popping on and in and out of the map, and then eventually you can actually download the raw data. And this is data across all the sites that matches all these definitions. So the dashboard really, the role it played, it was kind of like how to harmonize all our data that made sense as time series in one place, and then let people basically say, oh, I really just want all these things because the question I want to answer needs this kind of data in one place, right? So that's why it was helpful. Yep. Thank you. Behind the scenes, we basically, there's an actual RESTful API, and this is kind of interesting because it's really flexible. We built this from scratch, but basically anytime we put in data from these parsers, Python parsers, and get the data out, we do it with these documents that are GeoJSON. So there's the GeoJSON aspect, but also there's this property subdocument, which is open-ended. So you can actually put in, something that has a start time and end time and a location, which doesn't have to be a point necessarily, even though most of the time with the dashboard, it is a point. And then in that properties document, you can put whatever you want. And so this has been really helpful because over time, we started using it for things like provenance. So you see that source, that's the URL enclosure of the raw file from the loggernet, right? We have things like source line number. I don't know what that is, but it doesn't show up on the dashboard because we tell it that's not of interest to visualization, right? To visualizing the data. We have QA/QC things, and then we have, reverse stage, which we'll plot on the dashboard. But if somebody downloads all of this, they have all that information and they can use to then kind of, go back and get more information about the individual data points. And data points belong to streams and sensors and all that. Okay. Behind the scenes, how did we implement this? This is a Postgres database, and I'll say just one thing that is kind of interesting. We did a hybrid where it's a relational database. This is the data points table, and so we have a geography column that is PostGIS, so it supports projections, it supports polygons and all of that. And then that properties document is actually a JSON binary column where you can just put JSON in it. So it's really, really flexible. It's just Postgres. You get kind of a little bit of, the best of both worlds. And so it was a nice experiment. It didn't, under certain aspects, it didn't work out great, but it's kind of an interesting experiment to get, a little bit of both worlds, the NoSQL, the relational, and the GIS support. The whole thing was run on an OpenStack cluster, the NCSA. The interesting thing that I'll point out is simply that, even though we have 4 terabytes of data on disk, most of that is the LiDAR data set, obviously, right? But if you look at the geodashboard, the data points, we have about 5 million, but as you saw, each data point actually has multiple variables in it. So you can multiply by however many variables, right, you have on average. We have about 145 locations identified in the dashboard, but then we have, 74,000 files, raw files in Clouder. So last slide, we learned a lot of lessons about the geodashboard by doing this. One of the big ones, and so we're rebuilding it, and one of the big things that kind of did not work is how we were doing binning. So we have data over many years. It might be like at 1 minute resolution. We want to show it on the screen. And so what we do is we actually create these bins, representation by month, by year, by minute. And the way we were doing it before fell over. And we haven't deployed this yet. So we have redone it, and we actually store all the bins inside Postgres. So they're ready to be shown on our new graphs. So that's it. Everything is open source, and you can learn more about these URLs. Any questions? Thank you for your time.
We're gonna have some time for questions at the end. So. Oh dear, no. Don't want any of that. Oh yes. Basically, yes. Where do?
Close that, click on my Mac. There.
Where's Force Quit?
Yeah, Force Quit. There you go.
Do it.
Okay, and then let me do this and do this. Do this.
Wait for.
And
Okay.
A quick comment from the undisclosed location. We're seeing the presenter view with the next slide and all that. Oh, that's better. Thanks.
yes. And
Okay.
great.
Okay.
All
good.
yours.
Thank you. Okay, my name is Martin Seul. I'm working with Quasi. I'm the technical director there. I've worked there for 5 years, and we'll talk a little bit about HydroShare and Quasi itself, and how we work with the CZOs to help them do the data management. Okay, let's see. Good. So it's proven right to put the pronunciation of the acronym out there. So it's Quasi. It stands for the Consortium of Universities for the Advancement of Hydrologic Science. Who came up with that acronym? I don't know, but we are stuck with it. And what we are a non-profit consortium for universities. Right now, about 130 that are part of us, and we are funded through NSF. And our mission is mostly to work in the hydrology and water space, to do, or as a community organization, to strengthen the collaboration, to deliver data and models, and work with instrumentation. In addition, we have a big part about education that we are doing, and I'll talk about this a little bit. But the key issue that we are trying to do is we are focusing on the science support to enable science, and we are not a research organization, so we're really helping to facilitate research and not doing it ourselves. So that's a big differentiator between some of the universities we're working with. We are trying to help them. And our key activities are community services, data and model services, and providing data management for archiving data. And that's part that we do now with the CZOs. So Quasi is split in two different parts. One is the community services that almost has not a smaller part of the budget, and the bigger budget goes to the data services. But we are helping the community to do to learn instrumentation. So for your grad student, if you want something to learn a new method, you can come to us. We provide funding for people to learn new things. We have online classes that we provide. So it's a fairly large organization with a community organization to help with that part. The other part that's mostly my responsibility is working on the data services. So what we are trying to do is really help the researchers to do their job. So we are a long-term NSF data repository where we are funded to provide a landing place for data that's been created in the community. So that's why we come into play with the CZOs, because they need a place that is long-term, a long-term archive for the data. We create tools to formally publish data to support researchers. Everybody's busy, we know, so this should be easy, a straightforward process. Typically happens at the end of the process, just the day before everything goes live. They come to us, really put the data somewhere. There's a requirement now for many publishers to have the data somewhere, and we are providing one opportunity or one option to do that. So we're operating two cyber infrastructure tools. One is HydroShare for more file-based data, and HIS for time series data. And we are now recently also developed Jupyter Hub to really work with the data that sits in our repositories. In general, we are really driven by the community. So as I said before, we are a community organization. We are not making profit. We're not trying to build a product to sell, but really listen to the community, and all our data is also open source the same way Cloudera is. So feel free to ask questions in between if there's anything that is not clear. So, okay, so talk quite a little bit about the system, HIS system, and you heard it earlier in the mentioning from Colin that it's been around for quite a while. It's mostly based on time series, and we try to simplify the process for people to really be able to publish data with us. So we are hosting in the cloud. You're not required to do anything on your machine. You just come to us and request a data set. You have to conform to a certain standard of how to format the data, and this has been important because this forces people to add the proper metadata. Everybody's busy. Metadata attribution is not something that people do willingly often. So we have to a little bit force them to really do that with, if they have to adhere to a certain structure, otherwise the data cannot be published. So go to the process again, you upload the data, you request a publication for us, and then the data is available through a web service. If you want, you can get a DOI. So and the big benefits for researchers, you not need to do it by yourself, and it can then be found in our tool to really discover the data. Because it's called HydroClient, and it has around 100 different services from a small citizen science organizations to NASA data, USGS data. So you can go to one place, search for the data, and find time series data across many different time scales and organizations. Okay, so what happens if you don't have time series data? Then you'd come to you could not host it. So that's why we adopted HydroShare, because it can deal with all these different data sets. So it's a repository for hydrologic data, models, and tools. So again, it can take many different formats. You can just upload the data. and then discover and visualize it. So the big goals for what we're trying to accomplish with HyperShare for the community is to provide a long-term archive, to find a way for people to find and leverage the data. So to reuse the data, to not have data sit somewhere on a hard drive, and to collaborate and compute with it. So essentially, to do another step beyond being just providing the archive, to also have the ability to pull it into a notebook and walk with the data, for example. Some fun facts about HyperShare. So every time you sign up, you log in, you create your account, you have 20 gigabytes of space that you can walk with. This is the amount of data you can upload without any additional requests. If you want more, you could come back to us and get more. So we also host special data sets, for example, for the national water model, for Hurricane Harvey and Maria. So we've become an organization that helps other projects to host their data. So becoming essentially the back end for research projects. Right now we have around 2 terabytes of publicly available data, and if anybody wants to try it and needs help, just send us an email. We are happy to help. So I just walk quickly through a short basic workflow of how you would use HyperShare. So the first thing is to create data. So that would be a logger. Somebody has a data set that they are created. Someone makes a sample somewhere. So data gets created somehow, and then essentially you would just the next step would be you upload it to HyperShare. You can upload it as a single file. You can combine different files that belong together in an aggregation. So you can combine different things that are related and upload them. You are required to put a certain amount of metadata in there. The higher, if it's a private data set you only use for yourself, there's only a small amount of metadata you have to add. And the more if you want to make it public and get a DOI, you are required to add a certain amount of metadata. But the system will walk you through that process and give you the ability to add everything you need. Now, what can you do next with it? So once the data is uploaded, you can also share it with colleagues, and they can walk around it. So it's a little bit more than just a data dump. It really can help you to organize your group of researchers to walk around data. The last step would be, in case you are now done with the collaboration and you want to formally publish, you can get a DOI, and then it's a simple request to get that, and the data can become public. So a few more things you can do with HyperShare, and I just try to be more high level and not go into detail. We'll see a little bit more in the talk, the next talk. So this is our discovery interface. You can search for topics, the author tools. You can do a map search. So a fairly straightforward process of how data can be found. You also have the ability to pull your data into applications, meaning you're not just reliant on downloading the data. You can work in the cloud with the tools. For example, if you need your data to be accessed via a Jupyter Notebook, you can just open the data with a Jupyter Notebook, and then the data transferred into the notebook, and you can work with it. The same way, we have additional tools that work with data that sits inside of the application. So, how do we? So the system as is was created before we were approached by the CZOs, and there was an idea about how we can use the system to benefit the CZOs who had a need for a long-term archive. So that's how. So the idea really working together came because there was a unknown situation about the funding with the CZOs. The need to place where does the data go. So it had a little bit of a data rescue as well, because what do we do with it? Where does it go when the CZO's funding goes away? Or hopefully that is not the case, but there was a time when that was a little bit unclear. We had the long-term relationship with the CZO, so it's not something that we knew about. We were involved with that. We had data from them before, so it was a natural step for us to get engaged again with the CZO community. We have the ability, since this is an open source project, to adopt the HydroShare to work with the CZO needs. So we're not strictly, it's not a buy it and you use it, but we have the ability to really tailor it a little bit to the CZO needs. We try to do it not too much to not lose focus, but just determining what we can do for the CZOs. Okay, so that's pretty much all I had about HydroShare. I hope it was just more of a high level overview of what you can do with it. There's much more down detail in the technology that I'm happy to talk about if someone is interested in it. But I thought for this talk, I'll stay with the overview. So.
Yes, let's see. No, same thing. Okay, stop that. Start that, no. Okay, so I will do the clicking for David.
Okay.
So here's David Levinsky.
So this is David. Can you hear me okay?
I can, yes, there's affirmative.
Okay, I can pump up the volume if need be. Yes, so this is Dave Lubinsky. I'm going to disclose my location. I am in Boulder. And today I'm going to be talking about sort of the third phase of CZO data management. So this is the HydroShare portion. This is the ongoing portion. So next slide.
All right, next slide, come on. Easier said than done. Okay, there we go.
So to kind of set the stage here, so in late 2017, it'd been a while. We'd gone through these two eras of development that Colin talked about. And the goal for those eras was to come up with an integrated data sharing system for CZO. That didn't happen. There was progress made, and Colin talked about some of that, for pieces of it, but it wasn't finished in a comprehensive way, and the adoption didn't happen. So we didn't have the integrated system that we wanted to have, and one of the questions is why. Colin talked about some of these. Next slide. And one of the reasons I think is that the scope was just very large to try to build this integrated system. We're talking about pretty much all of the geosciences, all the disciplines represented in there. We're talking about a lot of the biosciences. We're talking about a huge range of data types, you know, everything from metadata that's streaming, that's coming in every second, to one-off Excel files that are being created in a lab. So, you know, certainly when we started, there wasn't really, there weren't too many groups to look at who had solved this. I mean, there are groups now like LTR and others that made great progress, but there wasn't much when we started. So the scope was really big. And partway through, the vision changed, as Colin mentioned, into a more granular sort of relational database approach. So that also added to the difficulties. And then I'm going to add a couple more lessons here. Colin talked about a mismatch, and I'll kind of put my own spin on that, my own opinion, which is that it seemed like the grant priorities were more for building and advancing cyber infrastructure, sort of the science of, the computer science of, and less about ending up with usable tools that would be adopted by data managers. So there was somewhat of a mismatch there. And then finally, I think something that comes up as a lesson for all of us, certainly me, is that the people aspects of this data management, probably should have been given more energy and funding and time up front. So like in this case, having a project manager probably would have been very helpful, because a lot of those roles end up being added on top of additional roles for the people who are building the stuff, and it would be more effective if that was up front. So next slide. So in 2017, we had gotten a little bit of the way shifting from completely autonomous individual set of 9 sites to a network, but we were still vastly in a situation where all the data management was happening locally. We did, however, have a central data metadata store. Next slide. And as Colin mentioned, that was just based off our regular website. Couple of the CZOs did adopt ODM2. I don't know how many people know about that, but the Observations Data Model 2, so a very granular database structure that handles both time series and non-time series data. So some of the CZOs integrated that, which is great. And as mentioned a little bit earlier, Miguel Leon at the Luquillo CZO built a great tool for managing those ODM2 databases, as well as visualizing and doing other stuff. So next slide. So that central metadata catalog, it was a sort of short-term fix. It was added on to our website CMS for good and bad. One of the good things is, because it was a CMS, it was pretty easy to just be generalized and cover the full gamut of data types. It's metadata only with links to data. So the data are not stored centrally. They're stored at the individual data servers principally, but then of course there's specific data sets that are in domain specific repositories like Open Topography. There's only about, well, I think this is a little out of date, but a little more than 410 data sets. That doesn't sound like much, but you need to keep in mind that these are composite data sets. So each of them are in turn pointing to, and then this is also out of date, more than probably on the order now close to 4,000 URLs of files and web pages. So for example, there's more than 3,000 files it's directly pointing to. And some of those web pages themselves are pages like that land on an interface for querying relational databases. So it actually spiders out to lots and lots of data, as you got a sense from both Colin and Luigi. It didn't, however, contain the IML CZO. So one of the 9 was not in the system. This is Luigi's one that had, because they were working Clouder. Next slide. So I'm gonna just do a little experiment with you here and make it a little bit melodramatic. So you can picture, somebody with a really deep voice, not me, saying, with a fragmented data sharing system, little money remaining. So the point here being that we did not have the integrated data sharing system. And what we haven't really talked about here too much is that CZO at the end of 2017 here was, we knew that that round of funding was ending. We didn't know what was coming next. Money was running out. We have subsequently found out, and actually is recently being announced, that CZO is officially ending next year. And we'll talk in a little bit, but NSF is still backing critical zone science, but it's going to be with a very different organization. So think time and money are running out. Next slide. So, what could we do at this sort of ending phase? Because we didn't have this integrated data system. We have these great systems like we saw from Colin and Luigi at the individual CZOs, but we don't have a lot that's integrated. What can we do? Next slide. So what we want to do is really focus, really concentrate on the top needs and some doable needs, sort of at the end of this decade plus of CZO. And the number one thing the data managers wanted and had wanted for a long time was a central repository. So this serves a number of uses, and as already has been mentioned a few times, one of the big things here is just data rescue. Long tail data is in danger of going dark, especially with CZO sort of ramping down. But it's also this opportunity to migrate all of our CZO metadata into a better system, HydroShare, as well as combine it with some data directly, which we've never had centralized, together. We can't grab all the CZO data. That's much too big for the scope of what we're doing here, but we could get at least the data that are easily scraped, harvested off public URLs. And another thing we wanted to do was add a little bit more structure to our metadata, where there's an opportunity here while switching systems to make it more findable and to expose it better. So for example, HydroShare already has a pretty good implementation of schema.org, so our data already shows up, for example, on Google Dataset Search. So we talked to the HydroShare people. We already connected with them. It was a logical choice. We came up with a plan. We obtained some funds from NSF. We started about a year ago working with the Kwasi team, with Martin's team on this. There's a small group working part-time, but we are planning to finish up in the next year on this, maybe early next year. Next slide. So what are the key kind of tasks here? What are we really covering? So one of the things with regarding that findability and structure was to create and improve the controlled vocabularies we're already using. So the principal one is that we had in our old and current system, because the migration's not done yet, we had over 4,000 terms being used for variables, different spellings and so on, totally uncontrolled. But we are now making those, narrowing down those 4,000 to a couple hundred standardized terms, and those terms are going into the ODM2 controlled database that's being managed currently by Jeff Horsberg at Utah State. So we, of course, needed to map metadata. The two systems, our old one and HydroShare, are different. We have a system already set up and have done tests on moving the metadata catalog. That works well. We have already done tests on copying data files, so thousands of data files. We can now harvest tens of gigabytes just from public scraping, and that works pretty well, and it gives us a good core. So we're mostly done with the first 4 tasks, and we're concentrating now on tasks 5 and 6, which I'll show you in a graphic way here a little bit in a sec, but just to point out, number 7 there is that we do have a pretty extensive sort of ending phase of working on training, support, and so on. So next slide. So that number 5, this sort of gets at the need for having CZO be a thing within HydroShare. So HydroShare currently has some great functionality around groups, which really helps us for the 9 observatories we have, but we need an Uber organization, and HydroShare is working with us and is extending the functionality to have what they call communities. CZO will be the first one. We're sort of the guinea pig, but they will roll that out in the longer term future to other communities. So that includes all the access controls and so on that needed for that. So it is a structural change to HydroShare that's pretty significant. I also should point out, and this sort of view we have on the right here is a list-like view. We're going to have IML as part of this. So the Clowder stuff that Luigi talked about, some of that's going to come in. It'll be the first time we have all of our metadata together, including some of our data. So number 6, if you change slide. So this a slide sort of gets at that metadata authoring I was talking about. So for example, we talked about having a controlled vocabulary for those what used to be 4,000 variable names now going down to several hundred. So that's not something that's in the structure of metadata for HydroShare. And we also have some other controlled vocabulary needs. And HydroShare is extending its functionality for CZO as a community to be able to work directly and in the interface that's already there with some new widgets and so on to add in more structured metadata than HydroShare has in its model, stuff that we would like to have, which is great. And equally important, and this was implemented quite some time ago, HydroShare has moved beyond the original system, which could only have files and you could only reference data that was locally stored on the HydroShare servers. now to be able to just point to remotely stored files. So you can have a collection that's both locally stored and remotely stored, which is great. So next slide. So just to kind of summarize here, when we focused down, we really had two main requirements for a central repository, as I've talked about, and this better searchability, findability. So of course, HydroShare's got those. But we also get these extras, and Martin talked quite a bit about these extras, like the online apps that are in the cloud, the connection automatically with data working in Jupyter Hub, access with the API, and so on. So this really does set up CZO even with this more modest focused project at the end as a bigger foundation for moving forward in the future. I should point out that it's a little unfortunate in some ways that HydroShare is called HydroShare, because even though CZO has a lot of hydrologic science, it obviously covers the full gamut of both bio and geosciences, and so the naming isn't great, but maybe we'll work on them for that for later. So with regard to the future, Luigi is going to introduce what's coming next in some sense with CZ Science from NSF. And that concludes it for me.
Thank you. Got it now. Go ahead.
All right. So death to the CZO, long live the CZN, I guess. About a month ago, NSF finally came out with a call for the new version of the program, the successor to the Critical Zone Observatories. And I think it's indicative that they dropped the term observatory and they adopted the term network. So please share the word. So this is text from the call, and the way they've structured it is that there is going to be between 8 and 10 awards, and these are thematic clusters. That means two things. It sounds like they're emphasizing this idea of having multiple locations, temporarily or fixed, and that the focus is going to be on the science, not necessarily on the observation. In fact, they do say could include existing observatories engaged in collecting environmental data. So I personally don't think that they don't want the thematic clusters to kind of gather the data themselves. They mentioned that at the end, the new sites will support the scientific goals of the cluster. But I think they want to emphasize that, you know, in a way, we kind of know how to gather the data. There's a lot of organizations doing that. So they want, these thematic clusters to go out there and integrate with those other observatories and pull in the data. So that's the thematic clusters on one end. On the other end, there's going to be this coordinating hub, and if you kind of remember the story, the timeline that Colin showed you, it really over time they created this network office, and I personally think it sounds like this coordinating hub is like the network office, with the addition of having the mandate to work on two things. One is oversee the compatibility and archiving of the data. Right, so they want to figure out how, okay, well, if you want to use this data, how do you make it compatible potentially against with other researchers and thematic areas. Also a mandate for archiving the data itself, which was not necessarily, I believe, in the prior phases mandate, and also kind of plan the infrastructure needs of the network. So I think they want the office to provide some leadership for all the thematic areas on how the infrastructure kind of will play out. So all of this is text from the call. So here's some questions that we kind of thought, and we have some time for discussions right now. So this is kind of like the beginning of our discussions, maybe not a lot, but here's some questions related to kind of the future of this kind of work and this call. So first of all, how do you ask questions that transcend place? Which in terms of data management, one of the kind of big questions is how do you harmonize data from the different data sources, different places, lots of assumptions, right? So how do you do that? Well, we don't have an answer, so here's a question. Maybe you guys do have some suggestions. How do you include existing data, right? So there's LTER. They say, well, go out and get data from other observatories. Well, how will the researchers know where to go get this data from, right? I mean, that potentially is a lot of burden on the researchers to figure out how to work all of that out at the different clusters. Do you have enough metadata to probably use the data, the usual thing. And finally is how to share the new data results with the larger community. So there's the call to the archival aspect, but there's also this idea that you will have the thematic areas kind of create their data sets as they work on their questions. And that data looks one way, right, while you work on it. And eventually, right, you get some results, you publish, and now you got that final version of the data that you have to share with the world. And so this short-term sharing, right, internal to the thematic areas, this is this long-term archival, right, so that when the thematic areas are over, somebody finds the papers, they want to get to the data, how do they two kind of play together? Distributed versus centralized, this was a theme, has been a theme over the years, as you have seen, and it's not clear in this case. I mean, is it centralized or distributed, right? Is that central office the final repository for data? What about before we get to that point? How do you move data, across those lines? And what technology do you leverage? Obviously, whoever puts in the calls will, propose different approaches, but is there something out there that would be really fitting for this kind of use case? So basically, yeah, that's it. So I think at this point we'll open it up for questions, not just on kind of the future and thoughts about moving forward, what this could look like, but also you've seen a lot of things, a lot of different presentations. Do you have any questions about any of the specific presentations?
Any questions about the presentations?
Or comments?
Use the microphone. Colin, would you be at liberty to maybe expand a little bit on the software stack that you used for your, or is it too much? It's more than 10 minutes.
Yes, and I won't have to kill you. It's open source. Though you may have, I can tell you a little bit of what we're using, and then you may have to ask again about more details. So basically, yeah, I'm happy to do so. I won't take too much time on it. We went from having a LAMP system, Perl, MySQL, Apache, Linux. And we switched over to entirely Node.js. We're using MongoDB for metadata, and we're actually time series database agnostic. Currently, we're using InfluxDB, and we actually still have that old MySQL server. Not MySQL, not MySQL. In any case, you got it. Came off the tongue. In any case, so those are the databases we use. We're using Node and JavaScript for all of our development. It's a bit of a shift for myself. And on the front end, we're using Vue.js, which is a framework for doing web apps. It's like React, but it's newer and cooler.
Yeah, right. That's the only difference I've heard.
So I'll leave it at that, and we can talk about it afterwards as well. Okay.
Anybody have thoughts on this new direction that NSF is proposing?
I have one thought. I'm actually from the repository that PLTR uses. If you want access to data, sorry, I'm from the repository that holds the LTR data. If you want to start accessing it, please let us know. Hi, Darren.
Thank you. We appreciate that. We may need it. You can also put in an application for the hub section. You'll have to read it several times. It's not clear.
Yeah, so I was kind of wondering, what do you think the emphasis is going to be on data-centric versus operations and science question-centric? Because, you know, in the past, NSF has always said, what are the science questions? We're driving this with the science. And the data, I mean, you're still picking up the pieces from decades of this mentality, trying to get to the point where the data that come out the back end are more than just the publications and quite useful. And so do you think that NSF has changed their stance here? And do you think you'll be able to make this data focused, or do you think it's ultimately going to have a lot of operations personnel and science-y funding in there?
I would actually argue that they are emphasizing even more strongly the science part of it. And I think this is we're all speculating at this point. There was actually a call yesterday morning for a clarification, which Richard Uretich did do a webinar. We have yet to find out whether that got recorded. So maybe some of this got answered already. But at the moment, my personal speculation on my part, they're hoping that a single data manager at a central office with an adopted archive will be sufficient, and that scientists can run around and do cool networky stuff out in the field without data managers. Now, you saw my talk. That can't be done by researchers, period, full stop. You need somebody to do that full time. So that kind of work would not continue unless it's specifically written into the grant and you just decide to budget on your own for that kind of thing. So I see it as a reduction in support for long-term data management, actually. Yeah. Any other opinion?
Yeah, I would just add to that that's I somewhat agree with Colin. I mean, read the call, because it's actually, there's definitely a reduction in that kind of support from the way they've kind of worded it. But I think that to a certain extent, I think they just want to centralize kind of the common practices, right, and the needs of all the thematic areas a little bit more. But I think there is room potentially for the thematic areas to have some of that built in, but you have to build it in, right? It sounds like the observatory, the idea was it's an observatory, right? You put the instruments in the field, you manage the instruments. This is more come up with your research question, like you said, right? That is really number one. But then if as part of your research question, you say that this data is not available anywhere, and I need this, data, and I need to put this instrument in the field, I hope, that would be funded and that would be part of it. But again, you got to read it. You got to read between the lines. It's not necessarily very, very clear.
So I haven't been tracking what's been happening with Neon more recently, except I understand there's been some chaos in that area. But are there any opportunities for collaboration with whatever Neon is currently up to in terms of their data management activities or otherwise?
Well, from our point of view of Quasi in the data center, so we have not spent too much time working with Neon because it's a little bit of a different domain. What we have tried to do is really, as part of the Vados client, connecting to the Neon data and making it available through our data portal. So they provide APIs and to do that as well. So, but we're always open to really work with other organizations to really do this. But for now, we have not worked directly with them building. Yeah. Do you work with them?
I was just going to add, I think whoever puts in a proposal for the network, basically proposes something, like that potentially. I think that they're open, to that kind of thing. Yeah.
Since you've, and because I come from a loosely organized network, do you have a sense after reading the RFP, how, one of the things that's not clear to me is how a hub could operate with a group of thematic research programs that it doesn't know anything about yet? I don't quite understand.
Yes, somebody said that too in a conversation about.
Because it's like
yes.
they want a hub and then they have
Yep.
8 to 10 of these projects and they're independent proposals.
And if you don't know what they are, how do you write?
How do you thematically standardize
I don't
among
know.
things you don't know what they're going to do yet?
Yeah.
Okay,
Great
good.
question.
Thanks.
That's a fantastic. I think everybody
There's
has
an
that
NSF guy
question.
out there. Let's.
Yeah, maybe we. Great question. Yeah.
So I would like to point out that's nothing new. That's how the CZOs were formed. We all had specific research questions for our individual CZO, and they actually had no relation to each other. And we were told originally not to do things in direct acknowledgement of each other, just do your own thing. And then we became a network. So this is actually nothing new for us.
This is exactly what LTER, how LTER evolved.
Oh.
And it's 40 years.
And then when it became a network, they started saying, okay, now find cross-site questions.
That's what they did.
Now find cross-site questions to answer.
Well, that's why I was hoping this idea of calling it a network from the get-go would have a little bit more coordination involved among these 8 to 10, whatever they are, participating projects, but it doesn't appear to be the case.
Right, and that network, that it's supposed to do that. So it's not just the data management. There is an aspect of actually coordinating the research, but how you can do that without knowing what the research is.
Okay.
I don't know.
Thank you for this wonderful panel and the remote participants.
Thank you for moderating.
Can I add one thing? This is David in Boulder again. I didn't hear what you just said. Sorry.
We just laughed.
You just ended.
Oh, I just ended and thanked the panel, but yes.
Oh, okay. I just one last quick thing that especially coming off that question of how do you design a hub when you don't know what the clusters are. That's one of the key questions on my mind too. Colin mentioned that yesterday there was a webinar held by Richard Uritich and others at NSF. And there's another one scheduled for next Wednesday. So if you are interested in asking questions like how do you design a hub not knowing what the clusters are, you might want to sign up for that webinar on Wednesday. You'll find links to it on the homepage of the CZO website.
Criticalzone.org.
Thank you.
Thank you.
Thank you.
Appreciate you staying here.